Hello, Kevin Holcomb, a technical marketing engineer with Cisco. I'm going to talk to you a little bit today about our Cisco Mobile ReadyNet. This is it's a combination kind of products and some technologies that we've invented to develop to make mobile communications work better and more efficiently. So the first part of that is the products. So we make embedded boards, and these are boards this is a router, for instance. Now, it obviously doesn't have any connectors that you could use, really. You're not going to plug an RJ45 into this or anything like that. But what we do is we provide these, I like to call them puzzle pieces. We provide these puzzle pieces. A system integrator can take those puzzle pieces and embed those into whatever kind of form factor a customer needs. They can use whatever kind of connectors a customer needs to use for extremely rugged applications. These are all, tested to mil spec for vibration and shock and vibration. So very, very rugged devices here. We've got two versions of a router, and we've also got an embedded switch here, which can be embedded by our system integrator partners. Now, our newest product in this family is the 5921. 5921 is basically iOS running on Linux, and so I've got just a general purpose computer here that's purchased right off the internet. I loaded Linux on it, so I've got full Ubuntu desktop here, and I'm running other applications on it as well. It's also a Cisco router. I've got iOS running on it, just like the normal iOS you might find on an ISR G2 or something like that. So one important feature we've developed to enable mobile communications is called, we call them radio aware routing. And it's actually a series of, that radio aware routing is kind of the umbrella for a couple of protocols that we've developed. One of them is called Dynamic Link Exchange Protocol. And what that allows us to do, it allows a radio to tell a router what the current status of the RF link is in real time. So in this example, we've got two radio paths. So we've got two paths here. These radios are Ethernet connected. So they look like 100 megabits per second up all the time to the router. So we've got two paths. How does the router decide which way to go? Well, in real life, this radio link could be 64 kilobits per second. It could be, and it's changing all the time. So we've got a protocol, allows the radio to tell the router the current status. So if we look at this now, I can run a command. I see that my primary link is 40 megabits per second. My secondary link is 20. So I'm choosing to go down the primary, of course. Now I'm going to degrade that with this attenuator, and I'm going to make my primary path look worse than my secondary path now. So I've now dropped my primary to 30 megabits per second. Secondary still at 20. So I'm still going down the primary. Now I'm going to do one more click on this attenuator, and I know that that's going to make me switch over to the other link. And the video that's playing here will not glitch. Okay, I just switched over. Didn't notice anything on the video. I'll run this step. Now I'm on my secondary path. I've actually reduced my primary down to about 19 meg. My secondary is 20. So that's without that type of feature, the video would freeze for 25 seconds until the routing protocol timed out. So that's a kind of a brief overview of some of the technologies we created and some of the products we have as part of Cisco Mobile ReadyNet. To learn more information about these features and products, you can go to www.cisco.com/go/embedded. Thank you.